Today we are going to continue to talk about the segment addition postulate. We have a couple more definitions that we need to discuss. I need you to have your notes out, and I want you to copy these definitions. A midpoint is the point that cuts a segment into two congruent segments, and the word bisect means to cut in half. Pause your video. When you're finished copying this down, press play again. Okay, now I want to explain this a little bit. If I take a look at the diagram below that I've drawn here, you notice I have segment AB and point C. AC is equal, measurement of AC is equal to the measurement of CB. And I can tell that by the tick marks. C is the midpoint of segment AB. Now when I talk about bisect, remember bisect means to cut in half. C bisects the segment AB. And the line L also bisects the segment AB. So it doesn't have to be a point. It's any geometric shape that would cut a segment in half or anything in half. That means it's bisecting that. So again, in this case, line L is bisecting segment AB. Point C is bisecting segment AB. And point C is the midpoint. Now, I want to do an example. So, you'll notice there is no picture drawn here. So since that's the case, I'm going to draw a picture. So, it says E bisects DF. Actually, I want you to draw the picture. Don't do anything else. Draw the picture and label it with what you know. Press pause on your video, and when you're ready to see the answer, press play again. So you should have drawn a segment. You should have had D and F as your endpoints. You should have had E straight right in the center, and you'll notice that I marked that it was in the exact center but with tick marks. And then I put the measurements. DE is 2y, put it right above there. EF is 8y minus 3, and I put it right above there. The next step is to set up an equation. Now, using 2y and 8y minus 3, try to write an equation that makes sense given the information. Press pause on your video. When you think you have your answer, press play again. Okay, what you should have done is said 2y equals 8y minus 3 because these two segments are of equal length. So what I did here was I solved my equation. I subtracted 2y from both sides, and then I added 3 to both sides. The next thing I did was I divided by 6 on both sides, and I got y equals 3/6, or 1/2. Now remember I talked yesterday about the fact that you have to be really careful about what the directions ask you to find. In this case, it asked me to find DE, EF, and DF. Those are the lengths of those segments. It did not ask me to find y. However, I had to find y in order to find the segment lengths. The next thing that you need to do is substitute in y to find the segment lengths. Press pause on your video. When you're ready to see the answer, press play again. Okay, when I substituted it in, I found that DE was 1, EF was 1, and the sum, DF, is the sum of these pieces, so it has to be 2. Now, I want you to give this one a try. Press pause on your video, and when you're ready to see the answer, press play. Make sure you draw a picture. So here's the answer. You'll notice I have my segment drawn. D is the midpoint. One thing I really wish I had drawn in here are my tick marks. I should have matching tick marks. And I'll notice once I have this in there, I know that these segments are of equal length. I can set for x plus 6 equal to 7x minus 9, and then solve for x. Once I get x, I substitute in, and I can find my segment lengths. If you didn't get it right, press the pause on the video so you can have a chance to check your work and talk to a neighbor if necessary. Okay, now there are really three types of segment addition problems. We've already seen two of them. One type was the kind of problems we had yesterday when we were given two pieces and the whole segment. Here's an example. It says C is between A and B, and I want to find X and the segment lengths. Press pause on your video. When you're ready to see the answer, press play, and then we're going to summarize how to set up this type of problem. Okay, what you need to do again is draw your picture. I have two pieces and I have the whole. So in this particular case, I'd set the whole equal to the sum of the pieces. I substitute in, I combine like terms, and I solve for X. When I find X, I substitute into each of these to find my segment lengths, and then I double check that when I add them up, it indeed is equal to the answer. Is it? Let's double check. Let's see. 10x minus 5 is 27. CB, something's wrong here. Let's double check this. CB is 6x minus 3, so that would be 18 minus 3 or 15. AC is 19 minus 3x, so that would be 10. Oh, I know. This is wrong. So when I substitute into AB, AB is 10x minus 5, or 10 times 3 minus 5. That's 30 minus 5, or 25. You notice how I caught my error this way? These two segments have to add together to equal the whole. That is type 1. For type 1, you add the pieces together and set it equal to the whole. The next type is the type that we did at the very beginning of this lesson. We're given that we have a midpoint and or it's bisected, and you have the two pieces of the segment where you set it equal. Press pause on your video. When you're ready to see the answer, press play again. So again, I have my segment drawn. I've marked the two segments that are of equal length with tick marks, and then I set my expressions equal. 15 plus 2x equals negative x plus 9, and I solved. Notice that x is negative. X is allowed to be negative. The segment length is not. So when I substitute in, I find that KP is equal to 11. That's 15 plus 2 times negative 2. And PV is equal to negative x plus 9, and I end up getting 11 there as well. So really important, you set these two segment lengths equal. You better find that when you substitute in, you get equal numbers. Otherwise, you've done something wrong. And of course, the whole segment is the sum of the two. So far, two types. The first type, I have two pieces of a whole set. I'm given the whole and two pieces. In this case, I'm given that something is the midpoint, and then I have the two pieces of that segment. There is a third type, and I think I need to do this one with you. So the third type is where you're given a midpoint or something's being bisected, and you're given one of the halves and the whole. So let's take a look at this. I'm going to do it from scratch. So the first thing to do is draw yourself a picture. It says that I is the midpoint of HJ. So I'm going to draw HJ. And I is the midpoint. I know that HI is x plus 1. And I know that HJ is 26 minus 4x. So the goal here is to find x. You'll notice that x plus 1 is not equal to 26 minus 4x. But since this part is equal to this part, I know that this is also x plus 1. So once I have that, I can treat it like the first type, where I add the two pieces together and it's equal to the whole. So I have x plus 1 plus x plus 1 equals 26 minus 4x. So this is 2x plus 2 That's equal to 26 minus 4x. And now I have to solve. So let's see, I'll add 4x to both sides. That gives me 6x plus 2 equals 26. Now I'm going to subtract 2 from both sides. That's 6x equals 24. And then I'm going to divide both sides by 6. So I find that x is 4. Now if I go back and plug in, 4 plus 1 is 5. The segment length here is 5. Let's plug in here as well. 26 minus 4 times 4, that's 16. This whole segment length is 10. And I need to check. This plus this has to be that. An alternate way of looking at this is saying, okay, well, if I have a half and it's equal to and it's part of this whole, I can take 2 times my piece and set it equal to the whole segment. You'll notice that this and this are equivalent. It's just different ways of looking at it. So there you have it. Let's see if we can summarize. We have 3 types of problems. The first type is where I'm given 2 pieces where they're not equal lengths and the whole. In this case, you take each of the pieces, add them together, and it's equal to the whole segment length. The second case is where you have something being bisected or you have a midpoint. And you're given two smaller pieces. Then you have equal pieces. You have piece equals piece. Now, the third case is where you have something being bisected or a midpoint. And you're given a piece and a whole. In that case, you set it up as 2 times the piece is equal to the whole. And then you solve. So 3 types of problems with a segment addition kind of problem. 3 different types. And that is the section. I would like for you to begin the homework that is listed in Schoology, and I will see you on Monday. Have a great weekend.